Hello, welcome to my channel. So today let's look at the Leetcode 1137 nth Tribonacci number. So the question is a Tribonacci number Tn is defined as T0 is 1, T1 is 1, T2 is 1, and then Tn plus 3 is equivalent to Tn plus 1 plus Tn plus 2. So given n, return the value of Tn. So the two examples, when n equal to 4, t3 is 2, so t4 is 4. And example 2, when n is 25, so the tn will be this pretty large number. And the constraint n is smaller than or equal to 37. And also the answer is guaranteed to fit within a 32-bit integer. So which means we don't need to use long for the data format. So this question, we can actually, firstly, we are going. I'm going to use a dynamic programming, and I will use a like array for the dynamic programming. But later I will do a like a optimize of space. So so the question actually is what either already give you this relationship. So I can actually, firstly I will define a function. Maybe we can call it dp, which we will have n plus 1 elements. So dp array, and then the question is already, so tell you the equation we need. So we actually can write the equation based on the equation in the question. So dpi plus minus 1 plus dpi minus 2 plus dpi minus 3. So this is actually the equation. And so what we need to is we just need to fill this fill the dp array from 0 till n. Then the answer is answer will be dpn. Also there is some initial condition. So initial condition also is pretty straightforward. So the dp0 is a 0 and dp1 is a 1 and the dp2 is 1. Yeah, so this basically explains the dp, the primitive dp solution. So the time complexity is O over n, and the space complexity is also O over n. So let's firstly implement the solution. Then we can do some optimizations. So firstly, dp, yeah, we define this dp, and then dp0 is already 0. But let's actually initialize all the three. Then we need to do a loop. Because we already have 0, 1, 2, so it's loop starting from 3. So dpi will equal to this, and then in the end we return the dpn. Yeah, actually, I think that's it. So let me run the example and maybe run the second example, 25. Okay, so it works. Oh, index one out of bounds for index. Oh, yeah. So actually, the n it's possible n will be 0, 1, or 2. So actually, n will not always be like a number higher than or equal to 3. So if we need to put a special condition of if n is equal to 0, return 0. If else, if n is equal smaller than or equal to 1, 2, then return 1. So yeah, this should take care of this problem. So yeah, so it should work now. Okay, yeah. So now let's talk about the optimization. So from this array, we actually found that DPI is only dependent on the 3 previous variables. So which means we actually don't need we only need to keep the storage for those 3 variables. We don't need to keep the variables keep those values before those 3. So so let's do the optimization. So for the optimization, actually we only need to have 3 variables. So like we can initialize dp1 0 as 1, dp1 as dp0 as 0, dp1 as 1, and dp2 as 1. Then in the loop, we actually don't need we don't need to use the entire array, so we can add those firstly add those 3 variables together. Then so this one is then actually we just assign the dp1 to dp0, assign dp2 to dp1, and then assign then the dp2 is equal to temp. Then what we can just do this. Then in the end we return the dp2. So this is because the optimization it's on the space. The time is actually not optimized. So this solution will be time O(n) and space O(n). So we don't need the DP array. We can just yeah, okay. So let's try if this one works. Okay. Yeah. Oh, okay. So this is the today's exercise. So let's do a summarization. So we have tried 2 approaches. Actually, it's one approach, but also we optimize the space. So we are using the dynamic programming and in the firstly, and then we have do the space optimization using variables. So and then the space become O(n). Time is still O(n). So this concludes today's talk. And so if you have a question, please comment in the video. And if you like it, please subscribe or press the like button. So thank you for watching. See you next